help! Time for homework help. Let's start. Welcome to the homework help, guys. Hope you're excited. You should be on page... Yeah, I'm so excited to do homework, Mr. Graham. Thanks a lot. You should be on page 100 and 101. Wow, this is a special moment, guys. We've been working in this workbook, and we've been using it to help review at home, and we're in the triple digits now. We're on page 100. Isn't that amazing? Isn't that exciting? And gee, I'm so happy for you. Here we go. Folding chairs are set up in a school auditorium for play. There are 16 rows of chairs, each with 28 chairs. How many folding chairs are there? This is a multiplication problem. Whenever a math problem says rows, be prepared to multiply or divide. And in this case, it's divide. 16 times 28. Now this is new and different. It is. I promise it is. Because you've got two-digit numbers. This is crazy. To solve this problem, multiply 16 times 28. I don't really like this picture. I think I will admit this is why you have teachers and not just books. Because I think the book, I don't know. It's kind of a lot going on and not that helpful. I like this a little better. You can also use partial products to multiply two-digit numbers. You know what? I don't like this either. I'm sorry, but I really don't. I really do not. But we need to know it. We need to know it. We can't ignore it. I want to ignore it, but we can't. All right. Let's look at the questions real quick. Why is this area model divided into 4 sections? All right. What are they talking about? They're talking about this right here. Why are there 4 different little boxes there? Well, it's because 16 times 28 actually has 4 different things going on. See the 1 and the 2 right there? You know that 1 and that 2 aren't really a 1 and a 2, right? They're in the tens place. So that's really a 10 and a 20. So they take the 10 and the 20 and they multiply them. See that 6 and that 8 at the end? They take that 6 and the 8 and they multiply them. But they also have to do that 20 times that 6. And then they have to do that 10 times that 8. So that's why there's 4 sections to show you all the multiplication that's happening. It's not just 16 times 28. It's like 4 different things happening all at the same time. Whoa, so exciting. And I guess if I showed you this model in class, it wouldn't be so hard to use. You know, I think that you could use it. But just looking at it by yourself as a kid, that's tough. So 20 times 10 is 200. 8 times 10 is 80. 20 times 6 is 120. And 8 times 6 is 48. They took all those answers and they put them on the bottom, added it up, and got 448. So, why is the area model divided into 4 sections? We just talked about it. Write it in your own words. It's because they want you to multiply all the different numbers by each other. And there's 4 different numbers. There's the 10, 20, the 6, and the 8. How do the 4 steps in the partial products equation relate to the 4 sections in the area model? So how is this right here the same as this right here? I'll tell you. First they did 6 times 8, just like in this picture, this area model, they did 6 times 8. Then they did 10 times 8, just like in the picture they do 10 times 8. Then they did 20 times 6, just like in the picture they do 20 times 6. Then they did 20 times 10, just like in the picture they did 20 times 10. So it's 2 different ways to write to find out that the answer is 448. So we talked about that. Write it in your own words. Wait, what did you say? What do you mean, what did I say? I'm a video. Just rewind the video and play it again. God, come on. Would the product change if 20 plus 8 on the left side of the model were changed to 10 plus 10 plus 8? Where is that? I have no idea what they're talking about. What? Oh, okay. This is I don't like this question. It's weird. Duh? Yeah. Okay, so there's 28, right? What 28? What am I talking about? See, there's 28 right here. They're asking you that instead of you multiplied, 20 times things and 8 times things, would it matter if you took that 20 and multiplied things by 10 and then multiplied things by 10 again and add them all together? Does it matter? Well, let's try that. Think about what 20 times an easy one is. Think about what 20 times 2 is. 20 times 2 is 40. Now imagine if we didn't do that, if we split it up and did 10 times 2. Well, 10 times 2 is 20. And then we did 10 times 2 again and added it. 10 times 2 is still 20. You see that we have 20 times 2 equals 40. And you see what happens when we take the 20 and split it into two 10s. However, are these two circles, these two big circles, still the same thing? They are, because when you add the 20 and the 20 together, they're still going to get 40. So they're saying if you split stuff up like that and you multiply and add it up at the end, will it still be the same? And the answer is yes. I don't like the way they asked it. I think sometimes this book chooses to ask you things in ways that are not as clear as they should be, but that's what they're saying. List two different ways that you could break up the numbers in 34 times 12 to find the product. Explain why both ways would have the same product. Okay, so you could do 34 times 10 and then put that in parentheses, and you can plus that to 34 times 2, and that'd be correct because I still have the 34, right? I didn't lose the 34, and all I did is I took that 12 and I split it into a 10 and I split it into a 2. But I'm still doing multiplying. They're both still being multiplied by 34. And then I add them all together in the end, and that's going to be okay. What's another way I could do that? That's one way. What's another way? Well, I could keep the 12 whole. I don't have to mess up the 12. And instead I can just multiply 12 times 30 and add that to 12 times 4. And as you can see, all I did was this time I kept the 12, but then I kept the 12 and I put it there twice, and then I multiplied the 12 by that 30, and then I multiplied the 12 by that 4 from the 34, and then I just add it all together in the end. They're trying to show you if you split up numbers, as long as you're still multiplying in the same way, it's all going to be okay. Now let's see if we have enough time in this video to multiply this stuff out. I think we may. Let's do the area model. I like that one better, and I think you might too. 27 times 21. Okay, so go ahead and make like a box and split it into 4 pieces. All right. 27 times 21. Well, what makes a 27? You've got a 20 and you've got a 7, don't you? Okay. And what makes a 21? Well, you've got a 20 and you've got a 1, right? So now do all the different things. Do 20 times 20. 20 times 20 is the same as 2 times 2, but you just add on those zeros in the end. How about 20 times 1? That's really easy. 20 times 1? Get out of here. 20. How about 7 times 20? 7 times 20, Mr. Graham? That's crazy. No, it's not. Because 7 times 20 is the same thing as 7 times 2. But since there's a 0 at the end of that 20, you put a 0 at the end of your answer. And 7 times 1 is super simple. Then you got to add it all up. If I were a kid doing this, I would add these two together first and these two together first, since they're already kind of like above each other. 0 plus 0 is 0. 0 plus 4 is 4. 4 plus 1 is 5. And then I would do 20 plus 7. That's super easy. That's 27. And then I would add it one more time, because you have to add them all up together. And I do 0 plus 7 is 7. 4 plus 2 is 6. 5 plus nothing is 5. So the answer is 567. And just because I'm nervous, I'm going to double check that on a calculator. 27 times 21. Let's go to my calculator real quick. 27. Where's my calculator at? Move, dictionary. Get out of the way, dictionary. I want to use my calculator. Okay. So 27 times 21 equals 567. 567. Cool, hooray! Da, 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 da. We are the smartest. Alright. This video is starting to border on the long side. So instead of doing every single problem for you, I'm still going to help you out. I'm going to set you up, but you're on your own, okay? So you've got 37 times 23, and I'd really love for you to try that box method again, the area model, where you do 37 times 23, and all you do is make 4 corners, and you take one of the numbers and you go, okay, 37 is a 30 and a 7, and 23 is a 20 and a 3. Actually, this might go fast. I might go with you a little bit. What's 20 times 30? Well, think about first, what's 2 times 3? It's 6, okay? And then you just add the zeros. Oh, that's easy. Now think about 20 times 7. Well, just think about 2 times 7. That's only 14. That's easy. But then you gotta add that 0. That one has more zeros because both of the numbers had 0. This one only has that 1 0 because only 20 has a 0. Okay. Now for this box, do 3 times 30. We'll just do 3 times 3. And then so that 0 that we forgot, just put it right there. And then 3 times 7 is 21. Alright? Now, I've done almost all of it for you. Here's your job. Add it all up. If you add every single one up correctly, you will get a final correct answer. Alright guys, all the time we have for today. If you have a long time, a sad time doing this, and you're like, oh no, I can't figure it out, ask me in the morning in class and we'll go over it, okay? Alright guys, have a good night. Bye.